Hello everyone, welcome to my channel. My name is Jaren and today I am starting a new series of videos that will cover Django security. Basically, I will explain different mechanisms to protect your Django application against various web application attacks. So the attacks include something like SQL injection, cross-site scripting, etc. Okay. Today we will start with SQL injection. Okay, so before we dive into the protection part, let's learn what actually is SQL injection. Okay, so consider we are building a HRMS application, right? And I am told to build a feature where the HR can add the employee details, right? So I create a table called employee with this schema. So we have the employee ID, the first name, the last name, age, sex, department, and designation. Okay. The SQL command that would run at the backend to insert data into each rows in this employee table would look something like this, right? Insert into employee values and then the set of values in the respective fields, right? So this is okay in the normal scenario, right? But consider there is a malicious hacker and he inserted something like this into the designation field, which is the last field in the table. Okay, the SQL command now becomes something like this, right? Instead of the normal value in the designation field, we now have something where we are basically completing the insert statement command in this part. So we have executive, this is completing this insert statement, and then we are deleting this command basically deletes the employee table, right? This one, and then because of the double hyphen, this part of the original SQL command is commented out, right? So this in effect deletes the entire data from the employee table, right? I hope you have understood. Because of this data, okay, the entire SQL command is now modified, leading to deletion of deletion of data from the table, right? So this is an example of SQL injection. Okay, so what I'm basically trying to say is that SQL injection is a vulnerability in which malicious data, okay, from the user, which is in this case would be hacker, is injected into the application and sent to an SQL database as part of an SQL query. Like we saw in the previous example, right? The malicious data is sent to the SQL database as part of an SQL query, and the database executes that malicious query, leading to devastating consequences, right? In the previous example, deletion of data from the table, right? So that basically is what SQL injection. Okay, next let's look at the possibilities of SQL injection in Django. We all know that in Django we use something called Django ORM, or Django Object Relational Mapper, to communicate with an SQL database, right? It has its own query set APIs, which will basically convert Python queries. So we actually write the queries to interact with the database in Python, okay? And then Django would convert those Python queries to SQL queries, right? That's how this entire communication with database in Django using the ORM works, right? Now, in this particular scenario, during the conversion, two things happens. One is called query parameterization, and second is called input escaping. Okay, these two things basically prevents SQL injection in a Django application. Okay, so let's learn how. Take the previous example where this was the malicious command that would have been created when we inserted this particular malicious data, right? Now in Django ORM, two things happens. First, the SQL query is created separately with placeholders, like say like something like this, right? So insert into employee values access. So consider that X is the placeholder. Okay, this is just for more of an understanding purpose, right? So let's consider these are the placeholders that has been created. Okay, then what happens is that the user provided input is inserted into these placeholders as standalone values, okay, and not considered as part of the SQL command. So if you look at this, okay, these data from the user are inserted, okay, into the placeholders, okay, as standalone values, and it doesn't consider this as being part of the SQL command itself. It's just values which has been given into this, inserted into this placeholders. Okay, so effectively what would happen is that even if a malicious hacker tries to insert this malicious data into the application, it will just get stored into the table like this. Okay, that delete operation doesn't happen. Okay, that's how Django ORM prevents SQL injection in the application. Okay, now let's take a look at the HRMS application. Okay, this is a sample demo application that I've built, and look at how Django ORM is working and how it is preventing the SQL injection, right? So I have this application. I have a table here where I can see a list of employees when I add them. Let's go and add few employees. So let's say employer is 1, Jarin Juice, 28, meal, same sales, and I'm an executive. Okay, I'll save this. This is here. Next, let's add another employee, Jeffin Juice, 23, meal from marketing, say, and he's also an executive, and save, right? So we have two records now, and if you look at the left, I have an option to search people. So let's say I'm just searching for someone like Jaren, and I have the result for that as well. If I search for someone like Jeffin, I have the result for that as well, right? So this is the basic application. Okay, and from the code, this is how it looks like. So basically I have a project called Django Security, and in the models I have created this model with all the required fields. Okay, and in the views I have this. Okay, so I'm capturing all the data from the front end and saving to the Django ORM. Okay, this is how it happens. Now if you look at it, even if we insert a malicious data, so let's just add a few garbage values. Okay, let's say in the designation like we discussed, let's say we add something like executive. Okay, completed, right? Or let's put it this way, completed, and then mention delete from. So it will not be the table name is not going to be employee, it's going to be app employee, because that's how it gets created in the database when we migrate. And delete from app employee. App is the application name that we created in Django, and then we comment the rest. Okay, when if I save this get inserted as the as a value, as the data. It does not delete anything from the application, right? So basically that's how it's whatever value we insert in the designation field gets inserted into the table as it is. Okay, it doesn't consider it as anything as a SQL command or anything. Okay, just add it as it is, right? So that's how the Django ORM protects the Django application from SQL injection attacks. There are, however, few exceptions in Django. Okay, so when we use Django ORM, in most cases we are protected against SQL injection attacks, right? However, in case of two APIs, two query set APIs for row and extra, okay, Django has not implemented query parameterization and input escaping. So there is a possibility that if you are using these two APIs, row and extra, then you will be susceptible to SQL injection attacks unless we implement few controls. Okay, and third, Django allows you to execute SQL queries directly without the Django ORM. So in that case also, the responsibility to parameterize our queries lies on us. Django does not do that. Okay, so in these three scenarios, we have to be careful. So first, let's look at row and extra. Okay, these two APIs are basically used to execute complex select statements. So let's go to the editor and see how it works. Let's take this section of searching for employees. Okay, how I have implemented this is that when I enter some text into the input, and when I click on this, okay, this button, okay, and a Ajax query is sent to the backend, to the views. Okay, so this basically is the view that respond to that Ajax query. Okay, so what I'm saying is if the request is Ajax, okay, I get the search term, and then using Django ORM, I filter out, okay, the search term. I filter the search term against first name. Okay, so basically insensitive search is what I'm doing, right? And based on the first name, I get the result and I pass it on to the backend. So that's how the search functionality works with Django ORM. And in that particular case scenario, because we are using Django ORM, it's perfectly safe. But to show you the issues with row, I've also implemented the same functionality using row. Okay, so what I will do is I'll just comment this out, okay, and uncomment it. Okay, so this is the wrong way of doing it. Okay, I'll come to the correct way of doing it, but first let's look at the wrong way. Okay, so I have created a query, okay, where basically I'm saying select star from app employee, where the first name is like, so here it's insensitive in case case insensitive. Okay, and I have this the search term which will get added here, and I'm executing the query. Okay, so this is a string, this is an SQL query string, and I'm executing this with row. So employee dot objects dot row, I'm executing this query, which is this. Okay, so what happens is, let's go back to the, yeah, so what happens is if I do something like this, it will search perfectly fine, not an issue at all. Okay, but what will happen if I enter something malicious here? It will basically get appended here into this, right? So let's enter a value, something like single quotes colon, then delete from app employee and the comment. Okay, what will happen now is this value, okay, will get added here, complete the select statement, and then delete the particular table. Okay, so just for the sake of it, I'll write a search term here as well. Let's execute it. Okay, let's go back and see there's a type error here, but let's refresh the page and see. Oops, the entire table is now deleted. There's no data in the table at all. The malicious data that we inserted here got executed, okay, and deleted the entire data in the table, right? So that was an example of SQL injection in row. Okay, now this is the wrong way of doing that. You should not be doing it this way. So what's the right way of doing it? So let's comment this out and go down. Okay, now like we said, we have to use query parameterization. Okay, so we have the query here up to this much. This is the correct query. Select star from app employee or first name like %s, right? Note that there is no single quotes around %s. That's a very important thing to do. Okay, just write %s and then comma pass the search term as a list, as one list. So if there are two like %s, we'll put search term comma whatever is the next value, right? But in this case, because we only have one, we'll have to put only %s and that's your search term. Now this is query parameterization. Okay, I'm putting search term as a parameter into the query, and this here is the placeholder for this particular SQL command. Okay, now let's see if this actually prevents SQL injection. Let's go back and let's add few data. Mail sales executive. Add one more. Executive. Okay, now I'll just confirm. Yeah, now let's go back and insert the same malicious data. So here it will be, I'll say Jaren, which will be the search term, this delete from app employee, okay, and the double hyphen, right? If I execute this, there's no search result that has come up in this value with this value, but if I refresh the page, the data is not deleted. Okay, I still have the data. So what happened was that the malicious data was used as it is. It searched whether there is any record with that particular first name. It did not get any, so it returned nothing, right? And when I reload the page, it came up again with the same data. The original data came up, so it's all fine, right? So this way, the query parameterization prevented SQL injection for a row. Okay, that's how we use it. So two things to remember: one, don't pass it in semicolons. Sorry, don't pass it with single quotes. Don't do this. This is not the right way to do it. Remove, don't add single quotes, and then pass the values as a list. Okay, that's how you implement query parameterization for row API. Similarly, you can use extra to do the same query. Okay, so I have it here. Okay, so we have employee.objects.extra where first name like the search term. Okay, this is similar. Okay, this is the wrong way of doing it, like extra like a row here. Okay, so let's go back to the table. If we insert a malicious payload like this, okay, so we have delete from app employee, comment it out. Oh, we have to have a yeah. So a malicious payload like this would also, something I clicked on the search button, we have the same error. I refresh it and that data is deleted. Same mechanism as a row. Okay, so it deleted the entire data, right? Because that's the wrong way of doing it. Okay, and in this case as well, the correct way is to parameterize the query like this. So you have employee.objects.extra where first name is like, here no single quotes, and pass the values as params list here. Okay, so this is again query parameterization. So you have where inside this extra itself, first you pass the SQL statement and then the parameters, okay, with no single quotes around %s. Okay, so if we go back to the table, let's add some more data. Okay, and then if I try and enter the malicious data, delete from app employee, delete from app employee, yeah, search it, no result, no search result. If I refresh, I get the data. It's not getting deleted. Okay, so that's the correct way of doing query parameterization using extra. All right, next we'll look into the correct way of using direct SQL queries. Next, let's consider this add button here. Okay, I'm adding things here, clicking on save, that gets saved, right? And it gets saved, right? So the normal way I did was to use Django ORM, but I can also use direct SQL queries to do this, right? So what I'll do is I'll comment this off, okay, and then I'll increment this. Okay, so I'm creating a new cursor to the database, and then I'm setting up a query where basically it has an insert into statement, app employee, or in all these columns, values, all these values, and then using string formatting, I'm adding these values to this location. Okay, and then I'm executing this particular query, right? Simple. Normal scenario, if I add, so let's add a record. It gets added, no issues at all. But consider a scenario where we are adding a malicious data in the designation field here. Okay, so in designation, I'm going to add a malicious field here. Okay, what would happen? So let me add another record which will contain the malicious query. Okay, so I'll add this here. I'll add this malicious data. So single quotes, closing bracket, semicolon, then delete from app employee, complete that, comment the rest. Let me save this. The entire data is gone. Basically, why? Because it was appending to here. Okay, in the designation field, I was appending it here. The value get appended here, and it got deleted. Okay, the first, the insert statement run, but the second statement was to delete, so the entire table got deleted, right? Similarly like before. Now this is definitely the wrong way of doing it. So the correct way is to basically pass, like you guessed it, query parameterization. So I'll have cursor.execute, insert into all of this values, percentages again with no single quotes, and then as a list the parameters here. Okay, same as before, no single quotes, then as parameters pass it as list. So the conclusion here is that we should be using Django ORM as much as possible. Okay, so honestly, since the time I've started using Django, there has never been a scenario where I needed to use these row extra for more complex operations. Django ORM took care of most of my queries, right, with ease, not an issue at all. But there may be some scenarios where you might need to use row extra or a direct SQL query. So when we are using that, ensure that we are parameterizing that query and not putting single quotes around %s, right? These are the two things that we need to be careful about when using row extra and direct SQL queries. So that's it from my end today. In the next video, we'll talk about another attack. And if you like this, please share, please like and subscribe to my channel. Thank you.